Welcome to the first in a series of videos on the topic of chemical kinetics. A previous series of videos had looked at the subject of thermodynamics, and as you will see, two fields answer two different questions. Thermodynamics answers the question, will something happen? A binary yes or no answer, based on the fact that energy moves spontaneously from high to low. That doesn't say how fast it will happen. That is the question Kinetics answers. It's a well-known fact that water will flow downhill. It will flow from high to low. However, a river will run swiftly, and a glacier, also made of water, will run much more slowly. Thermodynamics answers the question, why does something happen? Anything where the final energy is lower than the initial energy will happen because it will have a negative free energy. It does not necessarily mean it will happen today. It doesn't say how fast it will happen, and it doesn't say how it will happen. Kinetics answers the question, how does something work through the study of mechanism? The study of chemical kinetics, how fast a reaction works, once again started in the Industrial Revolution, when people were learning how to use chemical reactions to make useful or desirable products and in turn make money. How fast a reaction goes is central to this enterprise because everyone knows the old saying, time is money. The faster you could make the reaction work, the more stuff you could sell, the more money you made. This was not initially a perfect world because it ignored a second aspect of kinetics. How fast something goes isn't the only thing one needs to know. You also have to know, how does that particular reaction occur? If you don't know how that particular reaction occurs, you could have a very bad day. Hence, people started studying kinetics. Fundamentally, kinetics are simple. If I have a reaction of A plus B, absolutely nothing is going to happen unless I mix those two reactants together. If they are in separate flasks, nothing happens. Once I mix them together, they will then move on to form the product C. Because a reaction is essentially the result of a collision between two molecules. A and B can't react in separate beakers because they can't come in contact with each other to form C. So the rate of the reaction is actually proportional to the frequency of collisions between molecules. What controls this? What will tell you what the frequency of collisions are? What factors control the rate of the reaction? If one looks at collisions in general, for example, with cars, you can ask yourself, at what time of day do more collisions occur? The answer is going to be the morning and evening rush hour, for the very simple reason that there are more cars on the road, it's more crowded, and collisions are more likely to occur. So, by extension, the rate of the reaction is proportional to the number of molecules present or the concentration of the reactants. Another determining factor in a collision is how hard is the collision. If you park a car, you will have a collision. You don't have to go to the insurance company. No one will notice. Everybody's bumped bumpers. However, on a highway, you can have a lot of damage and a lot of injuries because there is high energy present. The reason why is that the collision damage is proportional to the speed. For a molecule, the velocity of the molecule is proportional to the energy present. Energy is proportional to heat. Therefore, the rate of the reaction is proportional to the temperature. The last thing to look at in a traffic accident, a third factor in determining how much damage occurs, besides speed, is exactly how did the collision occur. Was it a rear-end collision? Was it a head-on collision? Or was it at an intersection and sideswiped in a T-bone type collision? For chemicals, how the reaction occurs is called the mechanism. So when studying a chemical reaction, if one wants to find out how fast it occurs and exactly how it occurs, one has to take into account the concentration of reactants, the temperature at the point of reaction, and the mechanism of how the reaction occurred. How these are determined will be shown in the following video, which is linked below. Thank you for listening, and I hope you found this useful.